Hi, in this video we're going to be talking about how to write redox reactions in acids. Alright, and here are the steps that we're going to take. So first, we have to write the oxidation for everything. And second, write the oxidation / reduction of half formulas. We'll call equations. Alright, so oxidation is basically the charge. The charge of an element. So if we have O2, that will have a neutral charge. And it will have a 0 of oxidation. If we have something like NO3 minus, the oxidation for, I'll show you what I mean when we're doing the examples. Balance the equations and then multiply both sides so they have equal number of electrons. 5, write them together and add H and O if necessary. And you're going to do that by adding H2O in the back and H2 in the front to make them balanced. Again, I'll show you what I mean when doing the examples. Finally, cancel and reduce. Alright, let's do an example. So we have here MnO4 minus aqueous plus C2O4 2 minus aqueous yields Mn2 plus CO2. Alright, so the first thing we're going to do is write the oxidation, and that's basically a charge. So over here, we know that oxygen have a 2 minus charge, right? Each oxygen have 2 minus. So times that by 8, this has a -8 charge. And 1 minus 8 gives us -1, +7. That means this Mn will have a +7 charge, where the total oxidation for all of these oxygens will be -8. And we can write that by, -2 times 4. So this Mn is dependent on the charge of the whole ion and the charge of the oxygen. So over here is 2 times -2, which is -8, and this is +7 to make a -1 overall charge. Now over here again, this is -2 times 4, which makes -8, and what makes -2 out of -8? That means C2 will have a 6 charge, and each of these will have a +3 multiplied by 2. And remember, oxygen is always -2 except when it's in peroxide, H2O2, when it only has a -1 charge. So now this one is straightforward. It's straight up Nn2+, so we're going to write 2+. And this is CO2. Without any charge, that makes it neutral. So this is -2 times 2 of that, which makes -4, which means this carbon has a +4 charge. Let's make this all the same. +4 charge. Alright, now we look at this. What got reduced and what got oxidized? As we can see, Mn went from a 7+ to a 2+. And C went from a +3 to +4. Alright, so this, what happened to Mn? It gained electrons, right? To make it less positive. Gained 5 electrons. What happened to the C? It went from 3+ to 4+, which means it lost 1 electron to become more positive. Alright, now we're going to write these redox half reactions. So we're going to say MnO4 minus plus 5 electrons form our Mn2+. And our C2O4 2 minus makes our CO2 plus 1 electron. And now we finished our step 1. We wrote the oxidation, which is all these numbers. Now we finished step 2. We wrote the half reactions of everything, these two. And now step 3, we balance. What does that mean? We have to balance all the first we have to balance both sides, right? Mn matches CO. This one only has CO2, whereas there's two C's on this side. So we're gonna have to balance out by writing a 2 in front over here. And now both of these will be balanced out individually, right? Oh, and by adding a 2 over here, we're going to have to add a 2 to this electron as well. Alright, now we need to balance out. We finished step number 3. Now we need to do number 4. Multiply both sides so they have an equal number of electrons. And what I mean by both sides is both reactions. Alright, so this one has 5 electrons. This one has 10. Our goal is to make them the same number of electrons. So what we need to do is multiply this whole thing by 2, multiply this whole thing by 5. So it will become 10 electrons, 10 valence electrons, 10 electrons. So we have 2 MnO4 minus plus 10 electrons. It makes our 2Mn2 plus. And 5C2O4 2 minus. It makes 10 electrons plus, plus 10 CO2s. Now we need to rewrite. Alright, I should have rolled these two reactions over here, but it's okay, I'm just gonna write them again. Yields 2Mn2 plus, this M is capitalized, but Mn2 plus. Alright, down here we have 5C2O4 2 minus yields 10 electrons plus 10 CO2. Alright, and here's the deal. As you can see on the left side, we have 4 O's times that by 2, 8 O's. While on the right side over here, we do not have any oxygens. And that is where we come to step 4. So we're going to add H and O's if necessary. And it is necessary, so we're going to add H2O in the back and H2 in the front. What does that mean? We're going to add H2O to balance out these oxygens. How much extra oxygens do we have over here? 2 times 4, 8 extra oxygens, which means we're going to need 8 H2O, right? In 8 H2O, there's a total of 8 oxygens, which balances out our 8 oxygens over here. Now, that also gave us an addition 16 hydrogens. So we're going to balance that out by writing 16 H pluses on the other side as well. Alright, so we're going to add 16 electrons on the 16 hydrogens on the left side to balance all the ones over here. And when we're adding hydrogens, we will not write 8 H2s. Instead, we're going to write 16 H pluses. And that is the way you're going to write hydrogens. So now we have 16 hydrogens, 8 oxygens, and 2 Mn and 2 Mn, which balances everything out. Now let's look at this second half reaction. We have 20 O's, 10 C's, 20 O's, 10 C's. So everything is balanced, so we do not need to add our H and O. And therefore, we can just leave it as it is. So now we're going to write everything that we had from the beginning. Now, everything up there, plus 10 electrons, except we're going to add the left side together and then write the right side together separately. So after I wrote the ones for the top ones, these three are the top ones, and this one's the second one. So we're going to write that together, and we're going to write the right side together as well, plus H2O plus 10 electrons plus 10 CO2. Alright, now we come to our sixth step, cancel and reduce. Basically, we cancel out anything that is exactly the same on both sides. We have 10 electrons here and 10 electrons here. That is exactly the same. Everything else is not the same. We have Mn with charge, Mn with no charge. So we're going to write everything again, this time without the electrons, since they're canceled out. We have 16H plus. This time we've got to add the state of matter, because that's the whole purpose of the unit, right? Plus, gas by itself is a gas. MnO4, oxides are aqueous. Alright, so this would be aqueous, plus 5C2O4 2 minus, which will also be aqueous. And what does that make? 2Mn2 plus. Metal by itself is solid, plus 8H2O, water is normally liquid, and finally plus 10 CO2, gas by itself is gas. And that is our final redox reaction for this acid. I'm going to make another example about redox reaction in acids. So if you didn't fully understand with this video, don't worry, we're going to make another video. Thank you for watching.